Today we will be civil engineers and build a paper tower. Our paper tower will use limited materials to be both tall and strong. We'll have to use our knowledge of engineering to build this tower using only paper. Now that we know what we're making, let's make sure that we have all of our materials ready. Since this project is an engineering design challenge, you may choose how much of our materials to use, and for this project we will need 10 sheets of printer paper, one 9-ounce paper cup, some marbles or stones for testing, one blueprint worksheet, a ruler, some tape, a pair of scissors, and a pen or a pencil. Once you have all of your materials ready, we can start building our paper tower. We're going to start by designing how we want our paper tower to look. Grab your blueprint sheet to get started. You can choose to either make your tower super strong, super tall, or to try for both. Remember that we only have 10 sheets of paper, but we can cut and fold these sheets to get more use out of them. I'll design my tower now. For my design, I will create 8 columns and 8 braces. You can show your students how to create these to let them use columns and braces in their own design, or you can let them cut and fold the paper however they like. You can also remind your students to label their tower on their blueprint. And try drawing their tower from different angles. Once you've designed your blueprint, we can move on to building our tower. Paper is not a very strong building material, but there are some ways that we can make it stronger. We can roll our paper into columns and fold it into braces. First, I'll start with a column. To create a column, grab one sheet of paper and fold it in half lengthwise or hot dog style. Make this fold with a crease, and then cut along this line. Next, we're going to grab one of these halves and place tape along one of the longer sides. I will break off enough tape to the side, place it face down, and then flip it back over. Roll the paper upwards slightly, starting on the side without the tape. Continue rolling the paper over itself, and then fold it onto the tape to keep it in place. The thickness of your column will depend on how much paper you start with and how tightly you roll it. Here is my first column. You can now repeat this step with the other half of the paper. And since I want to make 8 columns, I will use 3 more sheets total to make 8 total columns. After repeating that process with 3 more sheets of paper, I now have 8 columns total for my tower, and I will set these aside for now. Next, we will create some braces. For these, take a sheet of paper and fold it in half widthwise or hamburger style. Mark this fold with a line and cut along that line. we'll use one of these halves for one brace. And next, you're going to want to fold this in half lengthwise or hot dog style. For this step, no need to cut or tape. You're going to just fold it again lengthwise or hot dog style one more time. Now we have this shape. We can go ahead and tape this closed. And with that, you should have a flat, sturdy brace for your tower. Go ahead and repeat that process with the other half of the original sheet of paper, and then I'll repeat it with 3 more sheets of paper to make my 8 total braces. All right, so now I have done 3 more additional sheets of paper, so I have 8 total braces for my tower alongside my 8 total columns for my tower. Now we're ready to move on to the building step. Another thing to note is that the project slides for this project have guides on how to make the braces and the columns for your students, so you can show that in class if they're getting stuck with the instructions. To start for the tower, we're going to take 4 braces and we're going to shape them into a square. Once you have your square, you're going to tape them into place. I find the easiest way to tape them is to take one of the braces, place a piece of tape diagonally, put the other brace at a 90-degree angle, and fold the tape over the back, wrapping around the braces to keep them in place. Repeat this step with the other 3 corners. Repeat this step again to make 2 squares total. Now that we have 2 squares, we're going to connect these 2 squares together in the corners using our columns. This will make a sort of rectangular prism, which will be our tower. Placing the columns into the corners can be difficult, so I like to do all of the columns on the bottom square first and then attach the top square onto the top. Make sure to add enough tape to hold the columns up, but don't go overboard. Your students may be tempted to use a ton of tape for these steps, so you may want to limit how much tape they get, or let them know that they should use only as much as they need. To attach the columns to the corners, I'm going to make almost an L shape with the tape on 2 sides, like so. And then place it centered in the brace in the corner, sticking straight up. And I'll repeat this step with 3 more of my columns. Now that I've added my 4 columns sticking up from my base, I'm going to add my other square on top. To do this, I'm going to start with 2 of the bottom columns and then attach the 2 top ones using the same strategy that I used to attach the columns on the bottom. Another thing to remember while doing this is that since this is an engineering design challenge, you can be building a completely different tower, and you should expect your students to build a completely different tower based off of the designs that they made in their blueprint. Now I am attaching the top columns. And then I will stand my tower back up, and that gives me the main body of my tower. Switching to a front-facing angle, you can now better see all of the ways that the columns are attached. And after we put the brace on the top, or the square braces on the top, you can see that we have what looks like a tower, but it is quite flimsy. So we're going to support the columns that we currently have with our 4 remaining columns. And we're going to create diagonal sections in each of our walls. And this should create triangles as you connect the bottom corner to the top corner, which will strengthen our tower because the triangles are stronger structurally than the squares that our walls currently have. So I will connect columns. And our columns aren't going to reach the full height, so I'm going to keep them with their base in the bottom corner and then attach them wherever they reach on the upper column. I will attach them to the bottom corner in basically the same way that we did earlier by making these 2 little L's with the tape and then using that to sandwich the column which is already there. And then I will attach this to the top of the opposite column on both sides. Like so. And then I'll repeat this step on all of the walls with our remaining columns, all facing in the same direction. So next is this wall. And finally, the 4th wall. And if I rotate our tower, you'll see all of the columns that we just added are facing in the same direction. And it's significantly more sturdy now if I try to move it, thanks to all of those triangles that we've added. Before we test, we need somewhere to put our weight on the top of the tower. When having students design their projects, make sure that you emphasize that they will need to have some kind of roof or flat area on top where they can add a weight to test the strength of their tower. Make sure to have this on your own design, and for mine, I'm just going to take an extra sheet of paper and tape it onto the top. Make sure to tape it tightly so that the weight doesn't slip through the middle of our tower. In order to tape it tightly, I'm just going to put some tape on the edges and fold it under onto the brace. And I'll do that on 2 of the sides while letting the paper kind of overhang on the other sides because it's a little bit larger than the top of my tower. And this should be strong enough to support the cup, but I'll add a little bit more tape on these sides to make sure. And there we go, my roof is secured. To test our paper tower, we're going to test for height and for strength. Allow students to tape their towers down to the tables if they're unstable, and then we can start our testing. So first, we're going to measure our towers to see who has the highest one. You can have your students who are going for the tallest towers compete to see who has the tallest one by putting them next to each other or by using a ruler. To test for strength, you're going to want to place a cup on top of the tower. You can have a cup for groups of students or have one for you as the instructor and bring it around to groups who want to test for strength. And we're going to slowly add some glass stones to the cup to see how much weight that my tower can hold. So as you can see, just barely, my tower was able to hold all of the stones. If you want, you can also use other materials to add some weight to the towers, or say once the tower doesn't collapse that the students have passed. And if your paper tower is not working well, there are some things that you can address. As mentioned in other projects, triangles are much stronger than squares. So if you have any support structures inside of your tower, which form a square, you may want to use some diagonal pieces to turn them into triangles. Students may also use very little tape on the joints of their tower, especially if you emphasize that they should be careful with how much tape they use. Because of this, their joints might be weak or flimsy, so you can advise them to add some more tape to their tower. Keep in mind, making a tower which is both tall and strong is very resource intensive, and because of this, students who are trying to achieve both may need to go back to their blueprint to specialize their design for one purpose. For my design, I was going for more strength, but because of that, I used a lot of materials in the walls, which is why my tower isn't as tall. So you can encourage students to identify what failed with their tower and iterate upon their design. And an example of this is when my tower was being tested, the roof was showing lots of stress. So you could advise your students to maybe figure out how to support the braces or the roof better. We now have a working paper tower, but how does it work? There are many important parts of a tower which contribute to keeping it strong. There are the columns, the braces, and the foundation. The foundation contributes to distributing the weight at the base of the tower into the ground. In our case, the braces that we have at the bottom are our foundation and distribute the weight of our tower into our table. Braces are the horizontal supports of the tower, and they are often hidden in floors. Columns are the vertical supports of a tower, and they are often hidden in the walls. In towers which have fully glass exteriors, the columns are often hidden behind the glass panels on the inside of the floor plan. All of these structures work to move weight and external forces, such as swaying from the wind, down into the ground and away from the tower through the foundation. We also talked about the importance of using triangles. Triangles as a shape are much stronger than squares, and many towers incorporate triangles into their walls in order to better distribute the weight. If the weight of the tower was sitting on one corner or column, it would cause that column to be under a lot of stress. So using triangles allows us to split the load of the weight on the tower and move it down one column and then away from the column as well. Now that we know how our paper tower works, there are some things that you can consider with your students, such as what challenges did we face by using only paper to build our tower? Did you make your tower strong or tall or both? And what are the important parts of a tower and what do they all do?